Okay. Okay, do you guys care if I sit down? Great, because I have a terrible headache. Shh, shh, shh. Listen up. Do you want me to come sit by you, you said? Okay, I'm going to sit right here. Is that okay? It's easier to sit on one of the desktops that are flat. So if I was going to sit by Gavin, I was going to kick him out of the way. Take his seat. Okay, hurry up. Sit down. So tell me what sequences are. Like we've been working with them. We've been working with sequences. So, oh my goodness, Dina. Okay. So we know it's a what? A string of, it's like a string of numbers. Do those numbers follow a certain, like, God bless you, pattern or order? Yeah, so let's write that. A string of numbers that follow a certain order or pattern. Now, typically, especially with this pattern does not have an M in it. Sorry about that. That's why I teach math and not English. Typically, we don't need a calculator to figure out what that pattern is. We've been pretty lucky. Like we can just add two, add two, add two. Like we can recognize the pattern. But sometimes it's not easy to recognize the pattern or to find the common difference, or in today's case, common ratio. So I want us to focus, like I want you guys to focus your attention on this kind of section right here. So the way that I wrote these notes, they're just tables. So we're going to focus on the first column of the table. So at the beginning, how many points are there? Okay. So at the beginning, that's a to the 1. That's my first term is 1. Does that make sense?
Yes.
Okay. After 1 minute, so my second term is what? What is it? 3. Yeah. Yeah. You were what? Oh, you were saying the symbol 2, a to the second. Got it. Got it. Okay. After 2 minutes, which is going to be a to the third, my next sequence, how many points are there? 9. Okay. After 3 minutes, so a to the 4, how many points are there? 27. Yeah. I'm going to squeeze that in there. So the question says, write the terms in the sequence. Well, the first term is 1. The second term is 3, and then 9, and then 27. How would you find the next term? Multiplying by 3. We're multiplying by 3. So here's what we want to put there. What are we multiplying by? Multiply the last term by 3. Right? We're always multiplying the last term, the one right before. Remember the one right before? We're always going to multiply the last term by 3. Okay? Does everyone feel okay with that? Okay. Can we go to that middle column? Okay. Let's give everyone a chance to think. Okay. No shout outs. Give everyone a chance to think. Okay. So let's give everyone a chance to think. Someone different. Someone other than Antoine or Kane is going to answer this one. Okay. Yeah. What do you got? You have an answer already? So a to the 1, a to the first term is what? It's 40. Yeah. A to the second term is 20. A to the third term, Naya. How many points are at that third section? 10. Write the terms in our sequence. So we have 40, 20, and 10. How would you find the next term? Subtract by 10? No. Divide by, say it again. Are we dividing by 10 or are we dividing by 2? Okay, so I want to tell you something. In a sequence, listen, in a geometric sequence, you multiply. In an arithmetic sequence, you add. right? We added a common difference, and in a geometric sequence, we multiply. So I know that we're dividing by 2, but I need to write that as a multiplication problem. So dividing by 2 is the same thing as multiplying by what fraction? 1/2. So we are going to multiply the last term by 1/2. We can't use divide. Okay. And that's good. That's a learning thing for us, right? Because you'll see when we look at the like parent equation, the explicit formula, you'll see. Okay. So next one. What is the first term? Second term. Third term. The third term is 12. The fourth term is 24. You guys are getting way too fast. Okay, so fill those in. 3, 6, 12, 24. Eric, what are we doing to find each term? Gavin. Yeah, we're multiplying the last term by 2. If I call on you guys ever and you don't want to answer, you know that it's okay to just say pass. You don't have to feel like pressured. I don't get uptight about that, okay? Okay. So, does that make sense? Okay, so there's something, this number that we're this at the bottom, multiply the last term by 3, multiply the last term by 1/2. This thing that we're talking about is called a common ratio. So the common ratio is the number that each term is multiplied by to find the next term, right? Does that make sense? You take the first term and you multiply it by 2 to find the next one. And then you take that term and multiply it by 2 to find the next one. Okay? Ma'am. Because arithmetic sequence is adding. That's what we learned on Wednesday, Thursday, Friday. Geometric sequence is multiplying. That's why. Okay?
Isn't arithmetic also subtraction?
Well, it's a negative, but we add a negative. It's called the common difference. You either add a positive number or you add a negative number. We're going to be able to multiply by a positive number or a negative number, but it's still adding the common difference. Like if you think about the equation that I wrote down for you guys, it's plus D. It didn't say minus D. Does that make sense? Okay, good question. So what is a geometric sequence? Well, a geometric sequence is a sequence in which, I just don't know how else to say it. It's a sequence in which the next term is generated from multiplying the previous term by the common ratio. So the next term is generated by taking the previous term and multiplying by the common ratio. Okay. In this little common ratio spot, whoops, sorry about that. In this little spot that says common ratio where we define that, we have a little bit of room there. And I want to tell you that the common ratio abbreviation is R. So it's R. And if you don't recognize what's happening right away, so like in the pictures that we just did, you guys were able to see exactly what was happening. You were able to tell. But if you can't tell what that common ratio is, you can take the second term and divide it by the first term. Or you could take the third term and divide it by the second term. Or you could take the fourth term and divide it by the third term. And that like whole little pattern goes on forever. So let's look at the red sequence, that last sequence that we talked about. So this R equals the second divided by the first means 6 divided by 3 is what? If I were to take the second term, oh, poop on a stick. Sorry. If I were to take the second term and divide it by the first term, that's saying 6 divided by 3, right? And is that 2? Yes. If I were to take the third term and divide it by the second term, that's 12 divided by 6, which is also 2. And if I were to take the fourth term and divide it by the third term, that's also 24 divided by 12 is 2. So you just take, to find R, if it doesn't like jump off the page to you, you take the last term and divide it by the one right before it. Okay? That gives you R. Are we good with that? Was that a thumbs up or a finger like question? You're awesome. Thank you, ma'am. Okay. So let's talk about Samantha on her swing. So Samantha is swinging, and it says at her highest point, she's 5 feet off the ground. This is how she is. This is her first height measurement. This is the first distance she is off the ground. So 8 to the 1 is 5. It says if he does not give her another push, each progressive, meaning every swing after that, will be 85% of the height of the first, like of the one before that. So here's what I want to do first of all. I need to turn 85% into a decimal. You can. It would be 0.85, yes. 0.85. To go from a percent to a decimal, you move the decimal 2 places to the left. So you might want to highlight that or write something important if you don't know how to do that. To go from a percent to a decimal, you move the decimal place 2 places to the left. Okay? So my common ratio is going to be 0.85. So if I wanted to find the second, like her height at the second interval, well, let's see, that's going to be the first term, 5 times 0.85. So someone tell me what that equals.
4.25.
Thank you, Hayden, 4.25. Did you do that with a calculator or in your head? Okay, cool. No, I'm just checking. Some of you guys are really like with it. So I was just checking to see if who we got here. Okay. The third term. How do I find the third term? You do the same thing. You take the previous term and multiply it by 0.85. What does that equal?
3.6125.
Perfect. What are you lost about, Kate? Where the 0.85 came in? Okay. Put in your calculator 85% of 5 because of means multiply. You have to read the words up the top. The swing will be 85% of the height. Okay. Let's do the fourth one. Let's see. 5 times 0.85. That's the first. That's the second. 3 point. Let's just round it. Give me 2 decimals. 3.3. We'll do 3 decimals. It's about 3.071. Are you guys okay with that? We'll say about. So notice I turned my equal sign into a little squiggly butt. Okay. So think about when we were finding the nth term of an arithmetic sequence. Remember the question, how many times did I have to add 10 to get the fourth term? We added it 3 times. That was the arithmetic sequence, n minus 1. How many times do I have to multiply by the common ratio to get the second term? When I want to find the third term, how many times am I multiplying by the common ratio? When I want to find the fourth term, how many times am I multiplying by the common ratio? So if I want to find the 10th term, I have to take this number and multiply it how many times? 9. Or 0.85 to the 9th power. Oh my gosh. That's why I specifically wrote those out like that. So watch. So 5, listen, 0.85. And I'm going to do 10 minus 1 as my exponent. But we know that 10 minus 1 is 5 times, hang on one second, to the 9th. What do you got for me, sir? You have a little button that looks like a triangle. It's called a caret. A caret?
Whoa.
Caret.
That's a lot of numbers.
It is. So let's just do the first 3 decimals. So yeah, first 3 decimals. So 1.158. I agree with that. I think that's good. Okay. Does everyone know how to do that in a calculator? Okay. Does everyone have that written down? Okay.
Do we only have 2 pages today?
No, we have 3, but the last one's a half a page. It's fast. Okay. So here we go. We're going to determine the common ratio, meaning we're finding R for each. They do look like the same numbers. They are the same numbers. I just want to show you mathematically how to find R. Okay, so if I wanted to find R, remember I said to find R, what do? I want you to tell me the math part of it. Did you have your hand up? You were going to give me an answer? Okay. What did I say? To find R, I could take the last term and divide it by the term that came right before it. What is 27 divided by 9? 3. I could also take the third term, 9, and divide it by the second term. Or the second term and divide it by the first term. All of those are going to give me 3. All of them equal 3. Because it's a common ratio, which is the same thing as an equivalent fraction. Okay. So what's the next term? Well, I'm going to take 27 and do what with it? What is 27 times 3? Perfect. Awesome job. So let's see. I'm going to just take the last term, 10, and divide it by the term before that, 20. And that's how I know that this is 1/2. That's how you can kind of see where the fraction comes in. Okay. 1/2. Well, let's see. My common ratio is 1/2. So if I want to find the next term, what is half of 10, Antoine? 5. To find the common ratio, again, I'm going to take my last term, 24, and divide it by the term before that. Well, 24 divided by 12 is 2. So my common ratio is 2, and 24 times 2 is? Yes, sir. Thank you. Are you guys understanding how to find this? Kind of? Okay. So, Corbett, I'm coming to you because you got this. I know you do. You do. We're going to walk you through it. We'll help you out. So, okay, that's great. I'm glad that you did that. So, Corbett, I want you to take the last number in this sequence and we're going to divide it by the number that came right before that. Well, can you tell me what that number is? No, I mean, what? Thank you, because I'm the note writer. You're the mather.
So I got like 0.3 repeating.
Can you turn that into a fraction for me?
How do I do that?
Hit the math button, and then it'll say, hey, you want a fraction? And you say, yes, yes. Enter, enter.
1/3.
There you go. So my common ratio is 1/3. I love that. So what do I do to find the next 2 numbers? Well, I have to take 36 times 1/3. What is that? 12, yeah. And then I have to find the next one. So I have to take 12 times 1/3. And what is that? 4. Multiplying by 1/3 is the same thing as dividing by 3. Good job. Okay. All right. Hayden, you ready? You want to pass? You want to tell us what the common ratio is of this one? What two numbers am I going to divide? Yeah, -75 divided by -15. And what does that equal? Hayden's got it. No shout outs. I want you to divide. I think you multiplied. Five. Okay. So we have to find the next 3 numbers in the sequence. Well, remember to do that, I have to take the last number and multiply it by my common ratio. So what is -75 times 5? -375. And then I have to take, to find the next one, I have to take -375 and multiply that by 5. And what does that equal? -1,875. And then to find the next term, I have to take -1,875 and multiply that by 5. Good job. Do you guys feel okay with that? Okay. All right. So there is a formula that says this is how you find the nth term. Remember, when you are finding the nth term, that is the explicit formula. That is the explicit formula. Okay. So let's talk about what all these numbers mean. So a to the nth, that's just the nth term in the sequence. Nth term of the sequence. That says nth term of the sequence. Nth. It's whatever number. Like if I ask you for the 12th, the 18th, the 20th, you replace the n with that number, 20. Okay. So it's whatever number term you want. Okay. All right. What's a to the 1 represent? The first term. Good job. What does r represent? Nah. What did we say r was? Common ratio. Oh my gosh, I just have to erase that. That looks horrible. Common ratio. And this n minus 1 gives us the position of the previous term. So if I wanted to find the 12th term, the n minus 1 would give me the term 11, because 12 minus 1 is 11. Okay. Now I'm going to write the recursive formula over here because I want you to know it. Remember that the recursive lets you find the one that came before. Recursive lets you find the one that came before. A to the n equals my common ratio r times a to the n minus 1. Just like if we were using, if you guys remember, you had to write the recursive formula 6 or 7 times last week. The recursive formula for a arithmetic sequence is a to the n equals a to the n minus 1 plus d, because we were doing the common difference. Okay, same idea. Okay, so we are going to use the nth formula. So basically the explicit, whenever it asks you to find the nth something, this is asking us to find, gosh darn it. This is asking us to find the ninth term, So what is a to the 1? Meaning what is the first term in my sequence? The first term in this sequence, it's 3. So a to the 1 is 3. What is the nth term that we're looking for? N is representing what number? 9. Good job. How are we going to find R? Well, I'm going to take the last term, 1.08, and I'm going to divide it by the one that came right before that. So someone needs to calculate that. Give it to me as a fraction. It's just the decimal 0.6. That's good. You can leave it as a decimal as long as it's not repeating. No, I'm going to leave it as 0.6. That's fine. As long as it's not a repeating decimal, you can leave it as a decimal. Okay. So R is 0.6, 0.6. So we're going to use this formula. I'm going to write it off to the side. A to the n equals A to the 1 times R to the n minus 1. And we're going to find the 9th term. So I need to know A to the 9. Okay, well, I find that by taking the first term. That's what A1 stands for. And what is the first term? 3 times R. What is my R value? Yeah, the 0.06 or 0.6, sorry. And then to the n minus 1. So if I'm looking for the 9th term, n is 9 minus 1. So really, I'm taking 3 times 0.6 to the power of 8. So find out what 6 to the 8th power is and multiply that by 3. Give me 4 decimal places. Good job. And I'm going to change those to squigglies because it's about. So let's talk about what we did. If we know the first term and we know what nth term we're looking for, and we can divide to find the common ratio, we plug all of that in to this formula. Okay, that's exactly what we did. So let's do it again. We're going to do it again. So for this next example, I'm trying to find the 7th. It says what's happening after 7 hours. So I'm trying to find the 7th term. Okay. What is the value of the first term? A1. It's 250. What is the value of n that we're looking for? What term are we looking for? What nth? The 7th term. How am I going to find out what R is? What am I going to divide? Awesome. And 1,000 divided by 500 is? So R equals 2. Okay. So I'm using this equation right here that I have highlighted. I know that I'm trying to find the 7th term. So instead of writing A to the n, I'm going to write A to the 7 equals, what is my first term? 250 times, what is R? Raised to the power of n, which is what? 7 minus 1. Well, that's the same thing as saying 250 times 2 to the 7 minus 1 is 6. So what is A to the 7th? 16,000. Do you see how we did that? Okay. No, Gavin, you don't understand this? Okay. So these last two questions are kind of confusing because we have to work backwards. No. Was that in your packet? Yeah. Who said Mrs. Bischoff?
Said Miss Bischoff, why?
Why?
Yeah, why we got-
So we close the door, hon. So honestly, I didn't think that you guys needed to learn the geometric sequence, and Mrs. Melby upstairs said that you guys need to be introduced to it because you see it in Algebra 2, heavy, heavy, heavy. So here's what I thought. I'm like, okay, well, I'm going to introduce it and we're going to play around with it a little bit, but I'm not going to test it.
Oh, thank God.
Okay.
Thank you.
All right, so here we go. So we're going to write an equation for the nth term. So we need to figure out what a to the n is to write that equation, right? Well, the first thing that we need to know is what r is. So I know that my a to the 1, what is the first term in my sequence? A to the 1 is 21. And what is r? So 189 divided by negative 63 equals negative 3, yes. So a to the n, which is the one I'm trying to find, equals a to the 1, which is 21, times r, which is negative 3 to the n minus 1 power. And that is the formula. That's it. Because we are just writing a general formula for the nth term. We don't know what nth term we're trying to find. Are we trying to find the 20th or the 30th? It doesn't matter. All we do is put that n number in for n. Okay? Let's do it again. What is my first term? My first term is 62. Oh, 162. Thank you. What is r? Well, r is 72 divided by 108. And what is 72 divided by 108 as a fraction? Because I know it's a repeating decimal. 2/3. Okay, so r is 2/3. So a to the n equals, well, remember that general formula. A to the n equals a to the first times r to the n to the minus 1 power. So I know what a1 is. My first term is 162 times what's r? 2/3. What am I doing to 2/3? I'm taking it to the n minus 1 power. So this is the nth. This is the equation that's going to let me find the nth term. It says use the given sequence to determine A1 and R and substitute your values in for your formula. That's all we just did. That's pretty basic. These last two are tough. Okay? They are. I think they're tough. Okay. So we are going to find the 12th term. So I'm looking for a to the 12th. I don't know what that is. But here's what I do know. I know what a to the 5th is. A to the 5th is 17. So I'm going to write that general equation. A to the n equals a to the 1 times r to the n minus 1. And we're going to plug in for a to the 5th because we know what that value is. So we know what a to the 5th is. A to the 5th equals whatever a to the 1 term is. Here's my common ratio, negative 0.4. And if I'm looking for the 5th term, what is my exponent going to be? What is 5 minus 1? 4. But I can even go one step farther. Don't I know what a to the 5th actually is, what that number is? So I'm going to replace a to the 5th with a 17. So 17 equals a to the 1st times negative 0.4 raised to the 4th power. Someone figure out what negative 0.4 parenthesis, put it in a parenthesis, to the 4th power is. Yeah, it is. Can you get A1 all by itself? How would you do that? I mean, this is just an equation. Can you solve for A1? Because right now that says 17 equals A1 times 0.0256. How could I get A1 all by itself? Basically, what's the undo of multiply? Divide. I have to divide both sides by 0.0256. So when I do that, what do I get? No napping. When I do that, what do I get? It's a terminating decimal, so give me all of it. I thought it was 664. Oh, is it 66? Okay, I wrote it wrong. No, you guys are on it. Good. So 66 equals the first term. Okay. So we're still trying to find the 12th term. We know what the first term is, and we now, we knew what R was, and now we know what the first term is. So can we find the 12th term? Yes. How am I going to do that? I would take a to the 12th equals this. Here, let me show you what I'm doing. I'm using this recursive or this explicit formula. A to the n equals a to the 1 times r to the n minus 1. We're trying to find a to the 12th, right? So I'm going to let n equal 12. So a to the 12th equals, well, we just figured out what the first term is, 66.40625 times, well, negative 0.4 is my r. And what is 12? If 12 is n, what is n minus 1? 11. So it is. So a to the 12th is what? I didn't solve it out. I didn't solve it. What is 66.40625 times 0.4 to the power of 11? Did anyone do that? Is someone calculating that for me?
0.00278528.
So negative 0.00275. Is that okay? And I put it about, or is it 276?
00278.
Oh, 278. What's the number that comes after the 8? Okay, so it's really going to be 00279. Because that's going to make me round that up. Okay. So I will tell you that I would accept either one of these. Okay. I would accept either one of those. Okay. Let's do it again. Does everyone have this written down? Okay. So we're trying to find a to the 5th, but I only know what a to the 7th is. So again, I'm using this formula. A to the n equals a to the 1 times r to the n minus 1. So let's solve for A1. That's what we're doing. We are going to solve for A1. And we're going to do that by replacing this at the very beginning. A to the 7th equals a to the 1st times my common ratio is 6 to the 7 minus 1 is 6 power. Does everyone understand where that came from? But we know what a to the 7th is, right? A to the 7th is what number? It's negative 113 equals a to the 1st times, what is 6 to the 6th power? So I'm trying to get A1 all by itself. What do I have to do? Divide both sides by the 46656. This says, listen to what, look what you have here. It's the same thing that we did on the problem before that. It says negative 113 equals A1 times 446,625. I want to figure out what A1 is. I have to solve A1 so I can write a formula. So we're solving for A1. So we got to divide both sides by 46,625. And we're going to get a decimal. What is A1? We need to know what the first term is. A1 is about what? I got 0.00242. Can someone verify my math? Did anybody else get that?
I got that, but it was like negative.
You know what? Because I think I took mine to the fourth, not to the. No. I did mine to the sixth. You got a negative number?
Yeah.
Oh yeah, because we're dividing by a negative. You're right. Good call on that, dude. So I messed up the second part. Dang it. Okay, well, that's all right. So this is a negative number. And we know that R is 6. So let's write the fifth. Let's find the formula for the fifth term now. So A to the fifth equals A to the 1, which is negative 0.00242 times my common ratio 6 to the 5 minus 1 power. So A to the fifth equals negative 0.00242 times 6 to the fourth. So A to the fifth equals negative what? Is it like negative 3.136? Is someone doing that on their calculator?
Negative 3.136.
So you could leave either one of these answers. What? Yes. Okay, so I want to talk to you about your homework. It just says, what do you know about geometric sequences? I'm not even answering it. It has a common ratio. Shh. There is not, yes, there is. Thank you, but I'm not having you do all 4 pages. Okay. Okay, no, you're not. Shh. So listen, you're going to do page 6 and 7, all of it. I want you to do all of page 6 and 7, and then cross off 13 and 14. So you're going to skip 13 and 14. Yep. Yep. You're skipping 13 and 14, and you get to choose one from 15 through 18 to complete. You're only doing one problem on that page. One problem on the back page on page 8. That makes sense? This means one problem on page 8. Yes, you may.